6.1 outline. I'm Raj and this is Shannon. So the first step, explain the difference between explanatory and response variables in an experiment. A response variable is a variable that measures an outcome or result of a study. For example, the amount of weight a student can comfortably carry depends on his body weight. So the backpack weight is a response variable because it is responsible for the body weight. An explanatory variable is a variable that we think explains or causes changes in the response variable. For example, the body weight explains the backpack weight, so the body weight is the explanatory variable. Number 2, talk about what makes a variable confounding or lurking. A lurking variable is a variable that has an important effect on the relationship among the variables in a study, but is not one of the explanatory variables studied. Example, there is a high positive correlation between nations with many TV sets and a higher life expectancy. But just because we ship out 1,000 TV sets to Botswana doesn't mean that their life expectancy will go up. The lurking variable here is national wealth. Two variables are confounded when their effects on a response variable cannot be distinguished from each other. The confounded variables may be either explanatory or lurking variables. Number 3, discuss what a randomized comparative experiment is and elaborate on the placebo effect. Alright. The randomized comparative experiment is one of the most important concepts in statistics. It is designed to let us make cause and effect conclusions. First off, the random assignment produces groups of subjects that should be similar before we apply treatment. A proper comparative design ensures that influences other than the experimental treatments operate equally on all groups. By using these steps, differences in the response variable must be due to the effects of the treatment. A placebo is a dummy treatment with no active ingredients. Many patients respond favorably to any treatment, even a placebo. This response to dummy treatment is the placebo effect.
Step 4 in the 6.1 outline is understand what makes something statistically significant. So when something is statistically significant, there's no relationship between the variables. An observed effect is so large that it would rarely occur by chance. The results are very far off from your null hypothesis, so it's not what you thought it would happen. It could occur because of a type 1 error rate of the hypothesis, meaning the results favor an alternative hypothesis instead. So the results may not go for what you were thinking, but it could support a different idea. And number 5, determine when to use statistical adjustment. So a good comparative study measures and adjusts for confounding variables. So you try to eliminate bias. It can also be used to add bias, but it's not what you want to do. You could put one result in favor of the other if you're trying to make something seem more favorable. Number 6 is discuss the basic principles of an experimental design, which includes controlling, randomizing, and using enough subjects for your experiment. So for experimental designs, experiments involve active data production, not just observations, that actively intervene by imposing a type of treatment. Controls are the factors that do not receive direct treatment in order to compare it with the treated variable so you can see what actually happened. Randomization is just randomly assigning treatments to the subject, so it reduces bias. You don't put somebody in a group that they already know about or something. Completely randomized design is where subjects are assigned to groups completely at random. And a block design is where subjects are randomly assigned to a treatment group after being divided into groups themselves.